Whenever we're integrating a rational function like this, probably the first rule that should come to our mind, at least to try, is the log rule. Because one, we know that there's no real integral version of the quotient rule, which is unfortunate. And two, the log rule is just a good fit because, the integral of du over u gives you a natural log integral. And so oftentimes we can fashion or mold these rational expressions like this into a du over u type of mold. So if you think it's the log rule, here's how you proceed. You would let the denominator be the u, because we're trying to get du over u. So we'd have x squared minus 6x plus 5, and then that would make the du equal to 2x minus 6, right? 2x minus 6 dx. All right. Now, if we were to rewrite this integral here, attempt to rewrite it, we would have the integral. The denominator would be u. That's great. Unfortunately, though, our numerator is not du, and so that's kind of unfortunate. But as we've known for some time now, you can very easily tweak what's in your integrand to work out relatively well if you fix a constant here or there or what have you. So here, if we have x minus 3 and I would like 2x minus 6, then what I can do is I can put a 2 in the integrand, right, in the numerator, and balance it with a 1/2 on the outside. And that's allowed, that's legal, because if you wanted to, you could pull the 2 outside, and the 2 and the 1/2 would cancel each other, and so they would negate each other and not even actually be there. So this is equivalent to the original integral, but it's kind of a win-win situation because the numerator now is 2x minus 6 if I decided to distribute that quantity there. So these terms here that I'm circling right now, the 2x minus 6 dx, all those together are the same as du. 2x minus 6 dx, that's equivalent to du. So that du, it doesn't really matter where you put it. You can put it in the numerator. Some people like to do that. Some people like to pull it off the numerator and put it at the end, kind of like the way we did for the dx, and have 1 over u du, and that's fine too. Whatever. They're both equivalent. We can't forget to put a 1/2 on the outside. Now, students ask me a lot of times, they say, well, Devin, you put the 1/2. Did you forget to put the 2? Should you have put the 2 inside the integrand? And the answer to that is no. Now, where did the 2 go? Because I kept the 1/2. Where's the 2? Well, hopefully what you said is that the 2 is embedded inside of the du. The 2 is in there, but it's a part of the du. Okay, but we'll just leave it like this. And so the integral, so we'd have 1/2, and the integral of 1 over u du, as we all know, would be the natural log of the absolute value of u plus c, right? And let's not forget the absolute values. Those are important. All right, so our final answer would be 1/2 natural log, and for our final step, we would go back and jot down whatever u was. In this case, x squared minus 6x plus 5. X squared minus 6x plus 5. Go ahead and replace the u with that quantity, and then plus c. All right. Now, the great thing about indefinite integrals, and I've said this a lot, is if you think that's correct, if you think that's the right answer, then by all means, take his derivative and see if it comes back to the original integrand. So you notice this integrand back up here, if I take away all the fluff that I added in here, his derivative should be this guy. Now, just one last thing in closing real quickly here. We'll notice this 1/2 out front. There's something small you can do with this guy. You'll remember there was a property of logarithms that said if you have a coefficient in front of your logarithm, it can actually be moved up into the exponent of the expression here. So, if we wrote this as natural log of blank to the 1/2, you recall a 1/2 power is equivalent to a square root. Now, since whatever's inside a square root has to be positive anyways, the absolute values are a little redundant here, so we can drop them, and we'd have natural log of the square root of x squared minus 6x plus 5 plus c. And so it's just a little cleaner. I don't know if you'd say that it's necessary to put in there, but it definitely looks a little cleaner getting this coefficient, out in front of that logarithm there. So anyways, this is how we do a general log rule problem. Most of these have u substitution in them, and so just be on the lookout for creating a u out of the denominator and then fashioning whatever else is in the numerator into your du.